Alright guys, we're going to loop back to chapter 8, which I consider more an informative chapter than anything else. It's worth reading, but it doesn't introduce any real coding techniques that I think that we ought to hone in on, unlike something like encapsulation and inheritance. So we'll probably get through it in a single lecture. We're going to look at the PowerPoint for it. Wrong. Right. Alrighty, software engineering, coding conventions, helper methods, encapsulation. We already kind of know what encapsulation is. Top-down design, stubs, merging driver method with driven class. So, this is all informative stuff. It's not like we're introducing new keywords or, anything like that. Alrighty, coding style conventions. This is just a bunch of source code that they consider good coding. Let's start with a discussion of documentation and style rules. Open up the PowerPoint, and then there's a section at the bottom called Notes that you can slide up. These are the instructor's PowerPoints, so you can see the notes. If I had uploaded the student PowerPoint, you wouldn't see them. So for a complete list of all the documentation and style rules, refer to Appendix 5 of your book. Okay, so basically, include a prologue section for each file. You ought to include the file name, the programmer's name, a blank line with 1 star, a description, surrounding lines of stars, spaces after the single stars, and a blank line below the prologue. So yeah, that looks pretty snazzy. Am I going to count off if you don't do it like that? No, but it looks pretty snazzy. Use a multi-line comment, put the file name in there, the name of the author. I've always said the date that you wrote it. But, the reason why is that you could then go back and you could add things to this description of the date of each modification that you make and an explanation of what you do. So you go back later and you make this program handle doubles as well as ints, September 11, 2017, and then your initials like that. And then somebody else comes in and modifies it, remove the ability to handle doubles, September 12, somebody else, ABC, whatever, So you could put a minor list of each change that you make. That's my extension to his recommendation here. And it's PowerPoint that's putting dots here rather than asterisks. I would have put asterisks there. So variable declarations. They want us to put all local variables up at the top of the method. You can get away with not doing that, right? You can declare variables anywhere. If you wanted to, you could do, you could stick an int, XYZ here, and with some value, and then a string here, s is equal to, sc.next, whatever, that kind of stuff. You can mix them up. What the book recommends is that you put them all up at the top. Some programming languages, like C, require you to do that. Other programming languages don't even care if you define your variables, if you declare your variables or not. I consider this pretty good style, but when I'm demonstrating code in my lectures, I tend to just declare the variables when I need them rather than scroll all the way up, add a new variable, and scroll all the way down, because that would make the code more, the lecture more confusing. Another exception I have to this is that if I have some variables that are only used inside of an if or a loop, I just declare them there. Like if I'm going to put an if statement. If, S1 is equal to null, and then I need some variables to handle this. If I need to use a string in order to ask the user what they want to do about it, you know, sc.nextInt, whatever, you know. I don't see anything wrong with that. I like encapsulating my local variables inside blocks of code that are subordinate to if or while statements. I would rather see string s defined here than way up here. So I don't quite agree with this, but it's not a bad idea to list a lot of variables up at the top rather than, you know, mix them in with your code itself, your variable declarations themselves. My one exception to that is I also don't mind declaring variables inside of loops or inside of if statements. Align your comments if possible. If these were all in Courier, which I'm not sure they are, what they mean by that is space them out so that your comments look kind of like this. Create student. Set the first, you know. Set the last. Do you have to do that? No, but it makes it easier to read. In some programming languages a long time back, you actually had to line things up in specific columns, and you had a column indicator, like, you know, row 70 was where your columns began. But, you know, nowadays we can pick where our columns begin. But, yeah, I consider that a good idea, but it's not a must, but it makes your code look more professional. You can see that that's what he did here. Of course, that was pretty easy because both of these were the same length. Include a comment for every variable declaration unless the meaning is very obvious. And again, I don't do that in my lectures. You know, I just create string s1 and string s2 and int x and stuff like that because I'm demonstrating keywords and function method calls and things like that. But it's a good idea. Describe your variables as you declare them. And if you declared all your variables up at the top of the body, then it's really easy to figure out what the code is going to do. You scroll up to the top of the method, you see a list of variables, you see a list of those descriptions, and you go, oh, I get it. This is going to create a student, and it's going to set its first and last name, you know, things like that. So notice the line of asterisks and surrounding blank lines that separate the instance variables and the constructors. They like this. I'm not so picky. But they want a blank line with a, they want a row of asterisks before your constructor, after your instance variables. I do totally agree that the constructor should be first, the first method in the class. And then when you're messing with NetBeans and you tell it to encapsulate and stuff like that, sometimes it pushes the constructor all the way down to the end. If it does that, I bring it back up to the top. And then they're showing a description of what each constructor does or what each method does. Now there's a better format for doing that called the, well, I won't say it's better, it's harder to read, but it's called the Javadoc format. And you've seen that to some extent in our code previously, I believe. I think the main method in every single project we create is documented in the Javadoc style, like that. Right? So that when you hover over main, or if you try to call main, it's not working. There it goes. No, that doesn't help. What it's supposed to do is once you add your Javadoc comment to it, then as you type the code, then it'll give you information about it. Just like system.out.printf gives you information about it. Or not. All right, forget Javadoc for now. I'm going to add a method to this. Public static int whatever, and I'm going to return a 1 out of it. And then there's an option under tools called Analyze Javadoc. It tells you what's wrong with it. Lists a whole bunch of things. Add a return tag, add an @return tag, remove the parameter tag, create a missing Javadoc for main. Alrighty, I'm going to do that. I'm going to fix all the problems. So that was under Tools. Tools, Analyze Javadoc. And now let's go back and look what it did. Return a 1, no matter what. Right, that's kind of silly, but anyways. Param args, which are command line parameters. Then if you come up to Tools, Generate Javadoc, which I'm not seeing. Maybe I'm going too fast. Alright, let me go find it. Okay, I thought NetBeans had a tool that would generate an HTML page of your entire project using the Javadoc to describe the methods. I'm not seeing that. Doesn't mean it's not there. I'll do a little bit of research on that. I'm pretty sure it's in Eclipse and a couple of other editors I've used. But what you can do is, you see what it added is it put this @return here and it let us fill it in. Returns a 1 no matter what. That's what I put there. And then I put in the parameter args, which are command line parameters. So now if I feel like it, I could type main and then I could highlight that. Then I could do right click, show Javadoc. And I was hoping it'd pop it up in a nice little page, but instead what it does is Javadoc not found. Either Javadoc documentation for this item does not exist or you have not added specified Javadoc in the Java Platform Manager. Okay, this is telling me useful information. But if I highlight the word main there and I do show Javadoc, then down here it tells me parameters, args, which are command line parameters. It can pull out all the information about that. And it should have been able to do that wherever I typed it, not just by highlighting that, because how useful is that? I'm going to try this one, whatever, I highlight it, and that one did work. It gave us the declaration for it, returns a 1 no matter what. You can describe what the method does. There is, found a good web page for it. I'll post a link to this in our Unit 2 notes. Java class example. The class illustrates how to write comments. @Arthur Catalan @version 2.0. Here's the description of it. This method prints a received message on the console. Now notice that they're describing my method. What I would do is I would actually put the word my method up here. And then it says param message string variable to be printed @C my class @deprecated since version 1.0. Okay, I'm just going to grab this and paste it into ours and then do that show Javadoc again. And at this point I'm happy if you're just watching. You don't need to type all this in. So public static my method that takes a string message. Why are you crossed out? Why are you crossed out? Well, can I use it down here? My method? Hello? What is it crossing it out for? Because of that, maybe. Get rid of that. Maybe I should have just typed it rather than cutting and pasting it. I think that introduced something which we weren't expecting. Okay, so we see that we can describe the method, we can use @param, and we can say that it's deprecated, and we can say C my class. Not sure why we would use all those. Let's go add those. I'm just going to delete this. That didn't work out too well. But some of the keywords we can use, we could describe the method above that, so let's do that. So here I'm going to say this method returns a 1. Wow, cool. Then I'm going to put @author Jeff, JGT. And then I'm going to put an @deprecated, indicating, here we get a list of them all. @deprecated, since version 1, we're just saying don't use this function anymore. We're going to include it in here. I noticed that @author didn't actually work there, so I'm going to delete that. And what I mean by didn't work is after I typed the @ it didn't list anything else. But I see one for parameter. Takes no parameters. Did I delete my own method rather than... Everything's being crossed out now. I've totally broken my code somehow. Hey, my method is not crossed out anymore. Oh, it's because it's deprecated. As soon as you add the deprecated keyword, it crosses it out. Well, what do you know? Now I know. Alrighty. So anyways, the parameter takes no parameters. Return, it returns a 1 no matter what. In that case, I may not use any of the other ones. @exception returns no exceptions. Not that we've talked about exceptions yet. So now down here, if I was trying to call the whatever method and I didn't remember what it looked like, I could right click it, show Javadoc, come down here to the output, and it says returns a 1 no matter what, throws no exceptions. Our params didn't show up. Did I goof that? Maybe it didn't bother describing any params because there weren't actually any params. Let's go change whatever to accept one. Int x. And then return x. Okay. So @param, make sure I got it right. Pass an int to be returned. And then return the int that was passed in. Kind of wondering why this is black, but we'll live with it. We're spending too much time on Javadoc. I apologize. This will be the very last thing we do with it. So I'm trying to figure out how to get Java whatever to work. So I'm going to highlight it once more, do show Javadoc. I come down here. It still isn't showing me the params. I'm not going to mess it in anymore. But you do see that it's showing what it's supposed to return, a description of what it returns, and a description of what it throws. And it should have done the params as well, and it didn't, so I'm going to skip that. All right, back to our PowerPoints. I'm getting tired of talking about coding conventions. In general, blank lines, use blank lines to separate logical chunks of code, just like adding blank lines, between paragraphs. Use meaningful names. Your variables, instead of being called X, Y, and Z, or P, R, and I, ought to be called principal and rate and interest and stuff like that. And sure, when I'm doing these lectures, I use small variable names just to make them easy to type. Sometimes I try to demonstrate good variable names, but like if I have an array of strings, I just call it AS or something like that. Is that really useful? But when we were doing an array of colors, or a queue, a stack of, integers, we tried to give it more useful names. Curly braces go immediately below the preceding line. Now the NetBeans interface doesn't like us to do that, or if you reformat the code, it puts the braces back on the same line as the if statement or the while statement. But you can change that behavior in NetBeans by going to Tools, Options, Editor, Formatting, and then you can describe how you want Java to look, specifically braces. Do I want my class declarations to be on the same line? Do I want my braces on them? No, I want them to be on their own line. Do I want my methods to be on the same line? No, I want the brace under them. All right, so there we go. Now if I do reformat, I highlight everything and I do source format, it moved the braces underneath the methods. You got to do that? No. It's a common code convention, though. On the other hand, this is a very common code convention, too. You're almost swimming against the tide by doing this because Java developers follow this one. But a lot of people also follow this one, and I find it easier to read, so that's why I use it. Textbooks also demonstrate it. Students mess up indentation a lot, makes the program very hard to read, looks unprofessional. Use proper indentation from the get-go. Don't just do it at the end. If it gets confusing, always go for the source reformat option, source format. All right, line wrap. If something is too long to fit on one line or fit on my screen, it's reasonable to break it up into multiple lines, and you've seen me do that with print statements. Alrighty, we're done with those. So methods normally use the public access modifier because most methods you want to be able to use from the driver, from the client code. The methods are considered to be part of the class's, quote, interface. You're defining your own interface, your own application programming interface for your class when you add methods to it. Sometimes you want to create a method that doesn't need to be part of the interface. It just supports the operation of other methods. Those methods are called helper methods, and they should use the private access modifier. So you can tuck methods away inside your class, which are only used by other methods in that class. I'm looking for a helper method. Okay, here's a class called shirt that has three members, three instance variables: name, primary, and trim. There's a constructor for it. When the constructor is called, it asks for the person's name, and then the primary, and then the trim. I am violently opposed to putting input and output inside constructors, but yeah, that's what he did. That's what they did. They have a display method, kind of like our toString methods, but that prints this shirt, this color, this color. All right, and then on the next page, they show the helper methods. Prompts for and inputs the user selection. So select color. Again, they declare scanner. I'm not really seeing why that would need to be a private one. But they did that because it's being called from within another method. They have decided that the only way you can access that function is within another function within the class. So they've written a function that allows you to select the color. The select color does a scanner. It asks them for all the information, forces them to get good data, and they made that a private method because supposedly it only should be called by the scanner. Now to me that looks like an ideal method to expose, to make part of the API. I have sort of a different definition of helper methods in my mind. The static methods that you make and add to a class, the class methods, I kind of think of those as helper methods, but So in the shirt constructor, note how we call select color. We don't use a reference variable prefix. Well, that's because select color was declared as static. No, it wasn't. It could have been. Because all it does is return a string. I would have declared this as static because you're not calling it outside anyways of the function. You're only calling it within the function. And it doesn't use any data at first blush that it doesn't use any of the instance data. It just gets a color and returns it. So I would have made that static. Why? Because it doesn't use any of the instance variables. If you find yourself writing a method that doesn't use any of the instance variables and doesn't call any instance methods, go ahead and make it static. So using helper methods can reduce code redundancy. In the Sure program, we called select color twice. Just to select the primary color and then to select the trim. That way we didn't have to copy and paste all that code about doing the input. Again, I question why it had to be private, why you wouldn't want to call it from the client code. So encapsulation, we've talked about encapsulation a lot. I'm not sure if we need to talk about it anymore. A program exhibits encapsulation if its data is hidden, if its data is difficult to access from classes outside the data's enclosing class. Why is it a good thing? Since other classes aren't able to directly access the encapsulation, it's more difficult for the other classes to mess things up. You can validate access to it. If they're trying to set somebody's salary, but the program client code has a mistake and is trying to set someone to a negative salary, your setter, your mutator, can weed that out. It can not, it can say, no, that's not right. I'm not going to allow you to do it. It could even throw an exception, perhaps, to force the programmer to fix the problem. So how is encapsulation implemented? To break a big problem into separate classes, where each class holds a set of encapsulated data. So if you have a sphere and a cube, you don't need to make one class that's both a sphere and a cube. You break them up. You put the data that involves spheres into a sphere class. You put the data that involves cubes into a cube class. And then if you want, you can make them both inherit from a shape class. But that's another topic. That's another lecture. Then you break the tasks into separate methods, where each method holds a set of encapsulation of encapsulated data. They're declaring that local variables are also encapsulated data. And that's a good point, I suppose. You don't want to put a whole bunch of instance variables in your classes that you don't need. And I'll give you an example of that. You don't need to type this in. This is kind of silly. But if we do new project, next, I didn't mean to do that. I actually just meant to add a new class. Excuse me. So, go to my projects, add a new class. All right, the only things that should be instance variables are things that need to be shared among multiple methods. So if I did this, void display, and I create a temporary variable, string temp is equal to string.format, I love my data, and then you print that out, system.out.println temp. And this is going to seem intuitive to you immediately, but you don't need to take that declaration and turn it into an instance variable. Maybe you think, well, why not make a temporary variable part of my class? And that way I could, reuse it through all my methods. But you wouldn't want to do that, because then calling another method from one method could destroy the contents of that temp variable. So if this called another method after we did that, and that method changed, it reused this instance variable, when we got back here, it'd be messed up. Whereas if this was always declared as a local variable, as many times as you needed to, then calling another method from inside this one would not mess up our temporary string. Another thing you don't want to do, and I've mentioned this before, is to not put what I would call cached data, results, things that should always be calculated. And for example, in our surface area of a sphere, or just our area of a circle, we put a radius as an instance method. And then my program assignment says, okay, write, something that'll return the area of the sphere. Lots of people want to do this. Okay, double area. You don't want to do that. If you're allowing them to change the radius, all of a sudden the area is wrong. even if you have another function that calculates the area. If you were trying to do that, then you would have to make it so that your setter and your constructor always calculate the area as soon as that data is changed. And that's kind of a drag. Area is calculated, so it should not be an instance variable, because then it's a lot of trouble to sync it up so that if it was dependent on another variable, every time that variable changed, you change the area as well. That's a simple example, but anything that you're going to calculate, make it recalculate. That's a general rule. If it's an extraordinarily complex calculation, I can see why you would want to cache its value. Meh. Algorithmic design with object-oriented programming. Given a problem description, what steps should you use to implement its solution? Now, I've been giving you too much description. I've been saying, okay, design a sphere and add a get surface area kind of thing. I could just give you a very general description. Write a program that, calculates the volume and the surface area of a cube or a sphere or a pyramid, and I'm just done with that. That's all my programs. That's all my problem says. And then the description under that says use object-oriented programming and classes to achieve this. Then you have to figure out, okay, I'm going to break this up into classes. What classes do I need? I should give you a program assignment like that that gives you more freedom to design these things. I'll think about that.
So I know a lot of people, like when it comes to their main class, they really only use like calls to other classes. Is that something that's common instead of writing so much code in main, or?
Right. The question is, how much code should you put in your main method? And an awful lot of people put very, very, very little code in main. And the reason you'd want to do that is so that you could give your classes to somebody else, or you could import them into another project. And that code that was inside main may be something that's useful to import, But if it was stuck inside of main, you can't import it, and you wind up copying and pasting it. So quite often, people will write a main that all it does is initialize and then call another method. Yeah, those GUI programs that we write tend to, we don't even see the main, I don't think, but if we do, all it does is it creates, an instance of a class, initialize a few variables, and then let it go. And everything else is in that other class. So decide on which classes you need. On my last problem, I said, it needs to calculate surface area for pyramids, spheres, and cubes. You go, okay, I think I need 3 classes. For each class, decide on its instance variables. You'd think, okay, I need to know, what variables are important to spheres, what variables are important to cubes, and what variables are important to pyramids. And then decide on its public methods. You go, okay, well, since I'm calculating area and volume, then I better make it get area and I better make it get volume, and I'll probably do it for all 3 of those functions. And depending on whether my program requirements said do data capsulation, then you should make all the data private and methods public, which means that you're probably going to give some getters and setters. Maybe not. Maybe you're just going to allow a constructor that sets those things. Those are your decisions if I don't specify them. So I really, now that I think about it, I really need to do that. Use top-down design for your methods. If the method is fairly involved, it can be broken into subtasks. You write, like a paragraph of code, and then another paragraph of code, and then another paragraph of code, and then you look at it and, oh, that first paragraph could be considered a subtask, and the second one could be considered a subtask, and then a third one could be a subtask. You put each of those into its own method. And if it would be a really bad idea for the client code to be able to call that, then you make it a private method. Consider it a helper method. For example, if you have 3 methods that have to be invoked in a row, it would be a real bad idea to let the client call those methods, because what if the programmer who's using your class calls them out of order or only calls one of them? That's actually bad programming, to write something that has to be called in a specific order in order to work. But you may find, when you're breaking these things into subtasks, that you want to do that. Try to avoid it.
So like that's for methods, or just in general? Like if you're like how we have prompts to add things to an array, and then how are we like sorting that array after? That's, you can't sort the array if the array is never created. So
right. So when would an example be of something that you might accidentally write in such a way that they had to be called in order? If you had a class that contained information about, about an array of data, and you added a get sum, and you added an input into array function. And so you had the array itself, you added a input, and then you added a get sum. You might mess up and make it so that you had to call the input function, or else the sum function would crash. And that would be bad. Instead, if there's no data in it, you just want it to return 0, if that's possible. If it's impossible, then you can't help it. But you don't want to make those dependent on each other. You don't want web of dependency to where it just flat out breaks. It kills your program if you don't call them in the right order. That makes sense? I want you to read this chapter, but I'm skipping some of the slides. Stubs. The idea of a stub is you make a method, but all you do is you declare its method header, and all it does is print out something. And so in our class that was manipulating arrays, as we're kind of specking this out, as we're trying to figure out what it's going to do, we write our class, we give it a name, and we know that it's going to need a input data method, and it's going to need a sum method. So you do private void input data, and all it does is print, okay, I'm inputting data, or just really in method name, whatever your method name is. And then on the sum method, all it does is print in sum, and maybe it returns a 0 or a -1 or something like that. Then you go back in later and you fill those in. If a program is initially entered with stubs, you can flesh out the skeleton of it and then go back in and add the detail to get it all to work. What he says is that when the programmer will be more easily get an initial successful compilation, the earlier you get your program to a point where it can be compiled and run, even if it doesn't do anything, the better off you are, because then you can keep compiling as you make incremental changes to it, rather than write 5,000 lines of code and you can't compile that until you've written it all, and then you have to correct 5,000 syntax errors. So debugging is easier. After the program is successfully compiled and run with the stubs, then you go in and you replace the stubs with actual code, one method at a time. Ideally, after each method is replaced, it's thoroughly debugged. And that way, if a bug appears, it should be easy to find, because it's probably in the new method that you just added. Now, merging your driver method into the driven class. So far, we've split, we skipped OOP programs where the book was concerned, but we've written our own, into 2 separate files. A file that not OOP, object-oriented programs. We've been doing object-oriented programming the entire class. For a minute, I thought that that meant GUI. So we've done a file that describes the object, like a mouse or a car or a sphere, and then a driver file with a main method. It's legal to merge the 2 files into one file, but we've refrained from doing so. Using 2 separate files leads to a more understandable problem. we'll consider doing that for most programs. But for short programs that don't do much except illustrate a concept, we'll merge the main method into the driven class. Why? It's a matter of convenience. I don't even agree with any of this. But say you have a sphere class. Okay, you have I'm going to change the name of this new class to sphere. So I'm going to highlight the word new class, and I'm going to refactor it, rename it to sphere. Refactor. Okay, cool. And all it does is get a radius, has a radius, and then, yeah, well, I'm not going to undo that. And it has a display method that says I love my sphere. Real useful. Okay. And then you put the driver code in the same function. Public static void sphere. Like that. And if it needs to take arguments, you could do that, but this one doesn't necessarily need to take arguments. And what does that do? To test it out, it creates a sphere. Sphere S1 is equal to new sphere. And then S1.display. This is the kind of stuff that we usually stick inside the main. No, that's not a constructor, excuse me, that was supposed to be a main. So we're adding a main method to our sphere class. And we could even make it a complete main method and not have a client method at all, in which case, we'd do, that. But then, over here in our application, if we wanted to run and test our sphere class, we could just do this. Sphere class main, pass the args in. I'd rather not pass in anything if it's not necessary. Why? Because, no, I'm not going to say that. He's arguing that you could make it so that you don't even need the client code at all, because the client code is built in to the sphere class. And some people have turned in code like this, and I urge them not to do it. I think the client code should always be in its own class, honestly. And there are a few exceptions. In GUI programming, quite often there's a main method that all it does is create an instance of that GUI and then runs it. Quite often as a thread. So you can do it. You just put a main method inside your class, and if you do the exact syntax, then you can go over to the projects, edit the properties for that project. I'm going to right click on it and do properties, and one of the properties is what is the main method. When you run it, what is the main class? What is the main method? And you click browse and it'll list it. Oh, okay, I'm going to run it with sphere as my main method, my main class. So you could have as many different main methods as you want. You could put a main method inside of every single class, and then if you wanted to test that class, if it had some test code down in the main method, it would work. Slightly different way of thinking about it. I don't really do it that way unless I feel like it's really strongly advantageous, or the library is leading me to do that. So here he had a time class, but he went ahead and added a public static void main to it that created a time object and then printed the time. And then when he wanted to test his time object, he could just make a project, throw that in it, set it to the main class, and then run it without writing a separate class that has a client, a driver. For a while now, we've used this to access instance variables. Do you have to do it? Sometimes you don't. You do use this in an instance method or a constructor to access the calling object's instance variables when you need to distinguish them from local variables or parameter names. But I say, and the book kind of says right here as well, just always use the this keyword. There's really no reason not to, unless you think it clutters up the way the code looks. Here he starts getting into musts. If there's a parameter or a local variable with the same name as your instance variable, you absolutely must use this in front of it. However, if there is no name ambiguity, you may omit the this prefix. I just like putting it in there all the time. For one thing, it's easier to type code if you can just type in, this dot, and it pops up all the instance variables, radius. Otherwise, I have to type out the whole thing myself, radius. Same goes for methods. If I wanted to call display, this dot display, once I start typing it, the IntelliSense goes ahead and fills it in, or lets me choose it. Whereas I would have to type the entire method. And it saves some time. Make sure that you don't get the uppercase and the lowercase, wrong and stuff like that. I find it advantageous to always use this keyword. But you can leave it out if there's no conflicts. If we had another local variable named radius right here, then in order to distinguish them, I would have to say this dot radius to specify the instance method, the instance variable. Excuse me. So here's our example. Our mouse has an instance variable named age. They set it to private, but it's still an instance variable because it's not static. And then they made a setter for it. The parameter for the setter was called A. And since there's no name conflict, the parameter name is different than the instance variable name. They just did age is equal to A. I like to do it like this. This dot age is equal to the age that you passed in. Why? So that when I look at the header for the method and I look at that, I know instantly, oh, I'm passing in the age, rather than, oh, I'm passing in A. Well, what's A? That's more descriptive. And that's what this does. In setWait, since we have a parameter named weight and we have an instance variable named weight, we have a name conflict that must be resolved by using the this keyword to refer to the class's variables, the instance variables. Alrighty. When this book explains helper methods, what sort of program is used as an example? I don't care. For a given program, it is legal to include a main method. Is that true? Can you put a main method in any class, and in fact in every class? Sure. Just in one class, and that class's name must end in driver? Well, that's absurd. We haven't been naming all of our classes absurd. Driver. Just in one class, and that class must be an anonymous class? We haven't done that. I'm not even sure we've discussed anonymous classes at this point. Anonymous Java class example. It's an inner class for which only a single object is created. And I forget whether it was in Java or C# that I defined a class in a class. I think it was in Java.
Did you define the class in a class? You've done it in C#.
I did it in C#. Okay.
And you did it at the end of Java because she was like, should I remind you to put this class in
its own file? Yeah. Every class should go in its own file. But an anonymous inner class can be useful when making an instance of an object with certain extras. Here's our example. We have a I'm not seeing their example yet. Here we go. This is crazy, but you could do this. Firstly, let's define a class inside of a class. We're going to make a mouse class, and all the we care about is the mouse's age. And then underneath it we could do mouse m is equal to new mouse, and that creates our mouse. That's not an anonymous class because it actually has a name. But we could also do this. Rat r is equal to new rat, and I'm getting the syntax wrong. I think that we have to be doing something that is based on inheritance. right? Okay, so let me revise that example. Since we're in circle, we're going to say circle R is equal to new circle, but then we're going to override some of the methods in circle, or we're going to add some to it. Still doesn't look totally anonymous to me, but oh, we call it sphere, excuse me. Sphere, S is equal to new sphere. And oh, by the way, I want a special sphere class that has a new value. Not only radius, but it's got, you know, string name. This is the name of my sphere. Alright, now I've created a new class that is effectively inherited from the sphere class, but it's got a new.
It's a sphere object, but it's its own class.
Yeah. So could we use it? Could we edit the name? Can we say s.name is equal to hello? Doesn't seem like it. But we could override a function that was already defined in it. We have a function up here called display. What if we wanted display to do something else? How did we define display? Just as void display? Okay. Void display, and our new version of it is gonna system.out.println. Haha, this is a custom display only for this sphere.
I guess in a real world example, when would that be useful?
When you're a heavy duty object oriented programmer doing a lot with inheritance. Honestly, I've never used anonymous classes in my life. I never wanted to define a custom override on the fly. But you can. So now that I've created a sphere, if I call s.display on it, it's going to print, haha, this is a custom display only for this sphere. And it's wanting me to add the override tag to it. Override annotation. It's bizarre. But you can do it. I don't recall what chapter this is introduced in. The idea of anonymous classes. So anyways, that's a silly answer. In one class and it must be anonymous? No. Just in one class and the class's name must end in driver? No. You can put a main method in any class. You can have multiple main methods, but in order to let it know which one you're going to run, you then have to go into the properties and set the main method that you are going to run. Now, since we moved the main, we selected our main method as being the one in the sphere. When we build it, it tells us the name of the jar file that's created. Right? Can I get rid of that? Here we go. So, here's the jar that it built, and if you wanted to run the jar, you would execute the name Java, the command java-jar, and you would specify the name of the jar. And since the jar's settings were determined by the properties of our project, it knows that when you ran that, it should run the main inside. Let's just copy and paste that into a command prompt. Run that entire thing. Let's see if it works. Well, yeah, it sure did, and we didn't get to see the result. Oh well. How about a command prompt rather than a run prompt? I love my sphere. Ha ha ha. This is a custom display only for this sphere. So you can run your applications from the command prompt. You just have to access the jar file. And so you have to give Java, which is the name of the of the executable, which provides the Java virtual machine, the runtime engine that supports Java, and then minus jar, meaning, oh, we're actually running it from a jar file instead of a class. Let's go see if we can find the class for that. It's going to be in user documents NetBeans projects. So cd user documents, cd NetBeans projects, cd Java app *10. Alrighty, let's find our class file. Your .java file is the source code, but once the compiler runs, it creates a bytecode file with the extension .class. And there's one inside Java application 10. Oh, inside build classes. Alrighty. cd build, cd classes, cd Java application 10. There's our classes, including the sphere class. So we could run it just by saying Java sphere. Could not load the main class sphere. Okay. Java, oh that's right, the sphere is just one of the classes in it. Java application 10. Okay, forget it. I'm not going to run it that way. Do we have the compiler available to us at the command prompt? Java C? Nope. So forget it.
I think you have to add the path.
Yeah, we would have to add Java C to the path and probably some other things to the path too. All right, that's enough of that. So there wasn't anything to turn in for this. So you watched the lecture. I hope you enjoyed it. Read the chapter. It's full of good advice, but it doesn't actually have any new programming techniques that we didn't already know, except for the concept of putting a main method inside a data class, which I don't really like to do anyways unless there's a really strong, compelling reason to do so. However, some of my students have been turning it in that way. I'd still rather you stick it in a client. But I guess at this point I won't count off if you put it, if you instantiated your main class. But I really do want you to name your class something useful. If you're implementing sphere functionality, don't just give me something that says homework10.java and that thing's got a radius and stuff like that. Make a different class called sphere, And then if you want to stick a main method inside your sphere class that runs it, okay, you can do that. Alrighty. I think that's enough. Are there any questions?